This conference will now be recorded.
Good morning, everyone. Am I audible? Yeah. So, last class, we have started with the peripheral called clcd. We understood what is clcd, how many pins are there in the clcd, where the pins are connected, what is the purpose of those pins, we have discussed. Then we understand about how to display the data, what kind of instructions, what are the different modes are there, 8-bit mode, 4-bit mode, in order to save our number of lines which we are using. Then how to know whether the data or the instruction has been executed or not, by using the delay method and the poll for d7 method we can do. And then we have understood what is the purpose of rs bit, r bar, w bit, and then the enable bit. Up to this we have discussed in our last class. Now what we will do, we will discuss more about the clcd. Okay. Now in order to understand about the clcd, we are having a separate data sheet for the clcd. Okay, separate data sheet is available. In your data sheet folder we will be having the multiple files, right? So among the third one is nothing but hd 44780 is nothing but the data sheet of clcd. Okay, we have to refer the data sheet of clcd. Okay, so this is nothing but your data sheet for the clcd. Clcd is having a separate data sheet. So in that, okay, we'll start with the page number 23, 24 or 25. Yeah. So yeah, page number 24, we will be having what are all the instructions are supported by our clcd. Okay, not only the position I mentioned already, like clear display, blink the cursor, like that we will be having many instructions on clcd. And we know that whatever the data we are passing or whatever the instruction we are sending it to the controller, both will be sent in the form of a binary, and with the help of the same data lines only. Now, for assume, let's say I want to clear the display. What this clear display will do, whatever the previous characters we have displayed, it will clear all the characters, whichever is previously displayed, it will clear all the characters. In order to display that, so what value we have to pass? What is the hex value? Here is my 8-bit of binary. What will be the hex value? 0x01. So to the data lines, if I assign the value 0x01, and we know that it is an instruction, and in order to mention it as an instruction, we are having the rs bit. So what we have to do, rs bit value we have to make it as 0. So if I send an instruction with the 0x01 to the clcd, what the clcd will do, it will clear the display. And we know that for whatever the instructions are supported by the clcd, all the instructions will be having the execution time. So you can see for all the instructions here how much time it will take. That execution time is also given. Maximum it will take 37 microseconds. In order to process the data, you don't need to worry much about it. If you want, you can more than provide this also, like 41, 42, like that you can provide. Maximum delay in order to execute any kind of instructions or a data, maximum it will take 41 microseconds of time. It can be any kind of complex instruction, but it will take just maximum delay, it will take us 41 microseconds of time it will take. Okay, so here for the clear display, there is no execution time, right? So you can provide the execution time as 37 microseconds of time. Okay, no issues in that. If it is not given, you can provide 41 microseconds or you can provide the 37 microseconds. 37, it will be the minimum value. Maximum CLCD requires up to 41 microseconds of time only. So here we will be having the multiple instruction. Now among this, I will highlight about one of the instruction called function set instruction. The instruction called function set instruction. So we know that like our microcontroller, sorry, our CLCD, it is having two lines. Okay, so we can display these many characters like that. We will be having something, right? So here you can configure some informations, and when it comes to the modes of data transmission, we can transmit 8-bit mode or we can transmit to the 4-bit mode also. 8-bit mode or the 4-bit mode, where I need to select all these things will be selected with the help of the function set instruction. So here other values are set, and here the values are like they didn't give any value. If they are mentioning it as some hyphen means, which indicates that bit is unimplemented, or you can take it as a don't care bit. You can assign 1 or you can assign 0 to that particular bits, no issues in that. That value will not be considered. That is why they have mentioned it as underscore. So now here we are having some characters like DL, N, F. So what it stands for? So in the function set, the first thing is DL, right? The DL, it stands for data length. Data length. With the help of this only, we can decide whether we want to follow the 8-bit mode or we need to follow the 4-bit mode. You can select any mode depending upon your requirement. If you want to use less number of pins, go with 8-bit mode. If you're not worried about the number of pins, then you can go with the 8-bit mode. Less number of pins, 4-bit. If you don't need to worry about the pins which we are using, then you can go with the 8-bit mode. So in order to select the 8-bit mode, the DL bit, we have to make it as 1. Whenever I set the DL bit as 1, 8-bit mode will get selected. Or if I clear the DL bit to 0, then 4-bit mode will get selected. 4-bit mode will get selected. The next bit is nothing but N. N, it stands for number of lines. Whether you are using one line or you are using two lines, that we can configure. Whether we are using two lines or we are using only one line. So whenever you want to use both the lines means, then the n bit you have to make it as 1. So we can program or we can use both the lines. Otherwise, if you want to use only one line, then the n bit we have to make it as 0. You can program only on the very first line itself. And the next thing is nothing but f. Okay, this f, it stands for font size. So with respect to the CLCD, our characters will be displayed in the dot matrix, like these many rows, these many columns. Based on that only, the characters will get displayed. So here we will be having our CLCD, it supports two different font. Okay, one is 5 cross 10 dots. Another one is 5 cross 8 dots. So 5 cross 10 dots is somewhat a bigger font. Okay, and 5 cross 8 dots is a normal font. Okay, so here you will be having restriction. Whenever you are using a bigger font, we can use only one line. Whenever you are using somewhat bigger font, okay, you can program only for one line. You cannot program on both the lines. And whenever it is 5 cross 8, you can program on both the lines also. Since it is a normal font, you can program on both the lines. So if I want to use 5 cross 10 dots, then the F bit, we have to make it as 1. Then we have to make the F bit as 1. If you want to use 5 cross 8 dot, then the F bit, you have to make it as 0. F bit, you have to make it as 0. So on our CLCD, first what we are going to use is, we are going to use 8-bit mode. Okay. we are going to use 8-bit mode. Along with the two lines I am going to program. Since I am programming on two lines, can I select the 5 cross 10 dots now? I want to program on both the lines. Can I select the 5 cross 10 dots of font size? No. We have to go with the 5 cross 8. So I'll be using the 5 cross 8 dots. 5 cross 8 dots. Now we have to write the value to the function set. So these are all the values we have to write. The remaining 2 bits, it is of don't care bit. We can write any value. So in order to configure this, these are the MSB bit. Now the next bit is DL. So I want to use 8-bit mode. So DL bit, it should be 1. Then the next bit is nothing but the number of lines. I'm using both the lines, so nth bit also it will be 1. Then the next bit is nothing but F. Font size, I want to use 5 cross 8 dots, so it will be 0. And we know that the remaining 2 bits are what? Don't care bits. We can write any value. So I'm just writing the values as 0 itself. To both the bits, I'm writing the value 0 itself. Now, can you tell me what is the hex value of this? What is the hex value of this? What is the hex value? What is the hex value? 0 cross 38. So in order to configure our CLCD, like how many bits we are using, like number of lines, the font size, in order to configure that, we have to write the hex value as 0x38. This will be our instruction in order to configure the things for the CLCD. Is the function set instruction is clear for everyone? And we have discussed one more instruction also, right? Which is nothing but clear display. Okay, to that what we have to do, the 8-bit values, it will be 001, which is nothing but 0 cross 01. If we pass the instruction as 0 cross 01, the CLCD, it will be clearing all the previous characters whichever we have displayed. Similarly, we are having multiple instructions. You can refer to this and accordingly you can select the values also. Okay, so now we'll discuss how to display a character. Okay, so in the last class itself we have discussed like where our data lines and the control lines are connected, right? So we are having 8 data lines and our 8 data lines are connected to the port D, and R bar W is already connected to the ground, so we don't need to modify anything. And our RS bit and the enable bits are connected to the RE2. Okay, so now first let's say I want to display something. Okay, so I want to display one character. So in order to display the character, I'm going to take one function like clcd put ch function I am taking. What the put ch function will do, which is used to display the character. One character I am going to display. So to this function, I will be passing two inputs as a parameter. One is nothing but our data. What is the data you want to display? Along with that, we have to pass the position also, where I want to display the data. So let me take that position as an address. So here, what address is representing? Address is nothing but the position. Address is nothing but the position where we need to display the data. So with respect to our CLCD, we are having two lines. We are having two lines. In each line, we can display 16 characters. We can display 16 characters, which means the position, it will start from 0 to 15, 0 to 15, like that. So with respect to the line number 1, the 0th position, Okay, the 0th position address is nothing but 0x80. This is the 0th position address for the line number 1. For the line number 2, the address is 0xC0. 0xC0 is the address for the line number 2. The addresses are fixed only. There is no changes with respect to the addresses of the lines. Okay, so that is for the 0th position. We are mentioning the address for line number 1 and the line number 2. So if you increment that address, we can able to fetch the next instruction. We can able to fetch the next instructions, right? So that only I have mentioned it as address here. So here we will not mention the position as 0, 1 or 2, that it will be in the form of an address only. It will be in the form of an address. So if you increment that address, we can able to fetch the next positions you can display. Okay, now here let's say I want to display a data called A. Okay, and I am passing the address as 0x80. 0x80 I am passing, which means at the starting position of line number 1 only, we will be displaying this data called A. Now, how to write the information to the CLCD? How to write the information to the CLCD? In order to write that information to the CLCD, which means what are the informations we have to write? We have to write the data to the CLCD, and then we have to write the address. Sorry, first we have to write the address, right? We have to write the address to the CLCD. Then we have to write the data to that CLCD. So in order to write the data or whatever the instructions you want to write it to the CLCD, we will be having one more function. All are our own function only. That's why I'm writing. Or there is no built-in functions and all. Okay, so now I am going to call a function called clcd write function. Okay, clcd write function. So with the help of the clcd write function, okay, we can write the data or we can write the instruction to the clcd. With the help of this function, we can write the data or we can write the instruction to the clcd. So to this function, again we will be passing two inputs. One is nothing but our information, like byte of information. This byte of information, it can be a data or it can be an instruction. The byte of information, it can be a data or it can be an instruction. Along with that, we have to pass the rs bit also. Okay, we have to pass the rs bit. Let me take it as mode. So here, what does the mode is representing? Mode is representing whether we are writing a data or we are writing an instruction. Okay, we have to mention the rs bit value. In the mode, we have to mention the rs bit value. Data means we have to mention the value as 1. Instruction means we have to mention the value as 0. So this is what we'll be mentioning inside this particular function. Now let me call this function first. So from the clcd put ch, I'm calling the clcd write function. To that write function, I am going to pass my information. First, I have to assign the address. So I'm passing that address. Along with that address is an instruction. Since it is an instruction, rs bit value, we have to make it as 0. So I'll be passing 0 as an input to the clcd write function. Again, what we have to do, again call the same clcd write function. Now this time I'll be assigning the data. Since it is a data, rs bit value it should be 1. Since it is a data, rs bit value it should be 1. So we are passing like this much is the put ch function. I'm just calling the clcd, right? Pass whatever the data we have to assign to the clcd. So first time I'm calling the function by passing the address and then the RS bit values as 0. So here I'm calling the function, right? So first, with respect to the CLCD, right, what we have to do. Okay, so in the CLCD write function, so first, let me one second. Yeah, first what we have to do, we have to assign the RS bit value, which is nothing but what mode we are collecting. So where our RS bit is connected, RS bit is connected to the RE2. So now to this RE2 pin, okay, we have to assign the mode which we are passing. So first I am passing the address as 0x80 and I am passing the mode RS bit value as what? 0, which means first I am going to write one instruction. So I will be assigning the mode. Then we have to assign the byte of information to the data, to the data lines. We have to assign the byte of information, whatever the address or whatever the data we are passing, that we have to assign. So our data lines are connected to the port D. So to the data lines, I'll be assigning my byte of information. I'll be assigning the byte of information. Now I have written the information to the CLCD. What the CLCD will do, it will start the processing. It will start executing that instruction. Now I should know whether the instruction has been executed or not. Whether the instruction has been executed or not. How will you know about that? How we can find whether our instruction has been executed or not executed? How to find that? Yes, we have two methods actually. One is delay method, another one is poll for D7. We cannot use the poll for D7. Why? Because our R bar W bit is connected to the ground. We cannot change the value of the RS. So we have to go with the delay method. And we know that we have to provide the clock pulse for the CLCD. That we will be providing with the help of the enable bit. Our enable bit is connected to the RE1. So what I am going to do here, to the RE1 pin, first I am generating the high pulse. Okay, so here high pulse will get generated. High pulse will get generated. Now here we have to add the delay method. We have to add the delay method. So now in order to add this delay, I'm going to use a built-in function. Okay, the function is underscore underscore delay underscore. Now I'm going to provide the delay in microseconds. If you want to provide the delay in milliseconds, then you can use ms. Okay, I'm going to provide the delay in microseconds. Now how much delay I have to provide? How much delay I have to provide? Actually this delay, it is for the clock pulse. Okay, because we need to generate the high pulse, then we have to generate the low pulse, again we have to generate high and low, like that this thing will goes on, right? Now how much amount of time I am going to generate the high pulse, like that you can just mention the state of a pulse. That's why I'm just going to add some less amount of delay in microseconds. Just 1000 delay is enough. After providing that high pulse, next we have to provide the low pulse. So to the same RE1 pin, I'll be assigning the bit as 0 in order to generate the low pulse. So at least this pulses is mandatory in order to perform this operation. Now we have to check whether the instruction has been executed or not. In order to check that instruction, we cannot go for the poll for D7. So here I am going to add a delay. Delay to execute the data or an instruction. We have to provide the delay. So same, I'm going to call the built-in delay function as microseconds. So now, as I said, like the maximum time our CLCD can take is 4.1 micros, 4.1 micros, or sorry, 41 microseconds of time it will take. Okay, the maximum time, okay, for our CLCD is nothing but 41 microseconds of time. This much, this is the maximum time it can take. Okay, not more than that. Can be any kind of instruction. Okay, so now I am going to provide the same timing only. I am going to provide the same time as a delay. So now here, what we did in the right function, first we assigned whether we are writing instruction or a data, which is RS bit I have written. Then I have written what is the actual data you want to write, or what is the actual instruction you want to write. So we have assigned our RS bit value and then the data bits to the data lines. After that, we are providing one clock pulse with the help of the enable bit, because clock pulse is required for the CLCD in order to process the instruction or the data. And the CLCD is not having any internal clock oscillator, so we are providing that externally with the help of the enable bit. After that, we have to wait until the execution is completed. So in order to provide that, we are going to use a delay, built-in delay function. Okay, I'm providing one delay. Okay, so for this built-in delay function, do I need to add any extra things like any libraries I have to include? No, it's available in our xe.h library. You don't need to add any other extra library. But if you are using the built-in delay function, we have to assign one macro. Okay, macro of our operating frequency. Okay, we have to assign one macro for selecting our operating frequency. Like we know that our microcontroller's operating frequency is what? 20 megahertz of frequency. So we have to sync with that time, then only we can provide this much delay, right? So how you have to calculate the delay, based on what you are calculating the delay. So here we have to define one macro for our controller's operating frequency. Our controller's operating frequency is 20 megahertz is our controller's operating frequency. So that we have to define it as a macro. I will show this macro later when we are when I'm opening that our template code. There I will show you. Now, among these two functions, do you have any doubts here? Do you have any doubts in these two functions? Okay. So we have discussed like how to display one character. Now what if I want to display a string? Okay, we'll discuss that. So now let's say I want to display one message. Okay, I want to display one message. So assume I have stored that to my to an character array. Okay, so now let's say I want to display a message called hello. I want to display a message called hello. Now, how to display this? Okay, so now what we are going to do, for that I am going to use another function. In order to display the string, I am going to take one more function called clcd print function. I am taking put ch, it will display only one character, and clcd print, it will display a string. Okay, so here what we have to do, first we have to pass what is the data you want to display. So I'm taking one data array. Okay, then followed by this, okay, followed by this, we have to pass the address also from where you need to display the data. So I'm taking one address, two inputs we are going to pass to this function. Now same here, here also first we have to write the address. We have to write the address. How will you write the address? In order to write the information only, we are having the clcd write function. To that write function, first we have to pass the address. Address is an instruction, so our rs bit value we have to make it as 0. After assigning the address, then we have to write the data to the clcd. Now, I want to write a message called hello, right? But how many data lines we are having? Only 8 data lines are available. Now, can I assign the whole message to the 8 bytes of data? Can I assign the whole message to the 8 bits of data lines? No, right? Because hello is a combination of multiple bytes are there. So what we have to do, if you want to display a string, we have to load the data byte by byte. So first H, then E, then L, byte by byte, we have to do this. So in order to write that byte by byte, I am going to run a loop. Okay, until I reach the null character. Okay, until I reach the null character, I am going to run a loop. One second, let me change the font size. Until I reach the null character, I am going to run this loop. Now inside this loop, we have to pass our data byte by byte. So for that, I'll be calling the clcd write function. Okay, clcd write function. So we have to pass our data to be returned, and since it is a data, our rs bit, it should be 1. Now next time I have to display the next character, so I'll be incrementing the data address. So first what will happen, I'll be assigning h, next I'll be assigning e, next l o. After that what will happen, we will be reaching the null character. So until I reach the null character, byte by byte, I am going to send the data. Now have you observed, inside the while loop, I'm just assigning the data, which means I have assigned the address only for one time. Only for one time I have assigned the address. Now let's say the address which I have passed is nothing but 0xc0. Address which I have passed is nothing but 0xc0, which means we will be having two lines, right? On our clcd, we will be having two lines. So now what I have written is, I have mentioned only the starting address, which means from that starting address, from the 0th position. Okay, from the 0th position of the clcd, since I have passed 0xc0, it will be displayed on the line number 2. So I'm mentioning the starting position, like from 0th position I want to start. So you don't need to mention the position for all the characters. Whenever you want to display a string, just starting address is enough for us. Automatically, the next address will get incremented. We don't need to increment the address. Automatically, the address will get incremented. So on clcd, if you're writing a string, means just mention the starting address. The next address, it will be taken automatically by the clcd. So to the next thing, the character will get displayed. Is that clear for everyone, like how to print the string? Do you have any doubts in this particular function? You want to make a note of these things? Yeah. Please make a note of this. Once you have noted, let me know. I will scroll down. Everyone, have you noted the print function? Okay. So now we'll refer to our sample code, okay, and we'll understand that also. So whatever we have written, same functions only. If few extra things will be there, we'll discuss that. Let me close all the other project. So it's available in our sample codes. So open project. You will be having the clcd sources, okay. In that, the second code, which is 8-bit driver code, okay, 8-bit code. So open that project. So since we are using a clcd, we have to take separate .h file and the .c file of the clcd. .c file, and then I'll be having main.c. First, we'll discuss with the .h file of the clcd. So I have told you, right? Like whenever we are using the built-in delay function, we just need to assign our operating frequency as a macro. So here is that operating frequency macro. So we have to define this macro. So here I have given the 20 megahertz of frequency. Okay, so if you're not adding this macro, then it will throw an error because we are using the built-in delay function. For that delay function, this is mandatory. If you are not providing this macro, then it will throw an error. So it's a mandatory one. Okay, then we know that to our tris-d, our data port is connected, and rs bit is connected to the re2, and the enable bit is connected to the re1. I have defined it as a macro. Okay, this is for setting the directions. I have taken this, and here is the port pins. Okay, data direction and the port pins, we have defined it as a macro. And we will be sending whether whatever I'm writing, whether it is a data or it is an instruction. So for the data or the instruction mode also, I have defined the macro. Data means we have to send the value 1, instruction means we have to send the value 0, and for high and low I have taken one macro. And here I have defined the macro for line number 1 and the line number 2. We'll understand this macro. Okay. So now we know that for the line number 1, the starting address is 0x80. Now, if I pass the line 1 as 0, I am passing. Okay, this is the macro. How it will be substituted? 0x80 plus 0, which is representing the 0th position. 0th position of line number 1. If you want to pass the different position, line number 2, from the 4th position, I want to display. Okay, from the 4th position, I want to display. Then what we are doing here, 0x80 plus 4, we are incrementing that address. So now at the 4th position, okay, our data will be displayed on the line number 1. Okay, this is how we'll be using this. So we can increment that starting address in order to fetch the positions and all. So here also we are doing the same thing for the line number 2. Line number 2 starting address is 0x80. If you increment that address, we'll be getting the address of the next position. Okay, and here I have defined some macros. So 8-bit mode, we'll discuss why this macro we have defined. We'll discuss about this. Now, two lines, 5 cross 8, 8-bit mode. In order to configure that, we have to write the values as 0x38. Just now we have discussed about the function set, right? That instruction, what value we have to write? 0x38 is our value. And clear the display screen. Clear display instruction we have discussed, right? For that, what value we have to assign? 0x0. 1. And here we have one more instruction. If you want, you can refer it in the data sheet of CLCD. Okay, so here what the instruction will do means our display will get turned on. Okay, and the cursor blinking, I'm turning it off. For that I have to write the values as 0x C0. What will happen? Our display will be on, but our cursor will get turned off. Cursor will get turned off. Okay, so for that I have defined the macro for the few instructions also. And here we will be having init CLCD, CLCD put CH, CLCD print, as well as one prototype is missing here, which is nothing but our CLCD write function. So in first we'll discuss about that CLCD put ch. We have discussed, right? We have to pass the data. We have to pass the address. So we'll be calling the CLCD write function and we'll be passing our information. Then with respect to the CLCD write, we'll be passing our data, which is our array, and then we will be passing the address. So only one time we have to write that address. We have to run a loop byte by byte. We are going to load our data. So I'll be running the loop until I reach the null character. So byte by byte, I'll be loading the data. So whatever we have discussed, the same thing is available here. So we'll discuss about the CLCD write function also. Same thing, to the CLCD write, we'll be passing the byte of information, and the RS bit mode also we will be passing. So we have to assign our RS bit value. Then we have to assign our byte of information to our data port. Then we will be providing the clock pulse, and then we will be adding the delay. In order to complete that execution, I'm adding my delay here. So I'll be providing the delay. This is what we have discussed so far, right? In CLCD put ch, CLCD print, and the CLCD write function. So here I have one more function, which is init CLCD. Whenever we use any peripheral, first we have to configure that peripheral. Like whatever the ports we are using, we have to set the direction for the ports, right? So here I'm setting the direction for the data port. Data port, we are writing the data. We are assigning the value to the data port. So it should be an output direction. Similarly, our RS bit value and the enable bit, both the bits, again we are assigning RS bit equals to 1, RS bit equals to 0, enable bit equals to 1. Like that, we are assigning the value to our RS bit as well as the enable bit. Since we are assigning the value, again the direction, it should be an output direction. So for the CLCD, we are using port D and port E. Accordingly, I'm setting the direction also. I have configured the direction. After this, I have one more function called init display controller. So why this function? Okay. So in order to work with the CLCD, like CLCD, it will be having some startup code. Okay, how our microcontroller is doing? Before executing our instruction, our controller will be executing one startup code, some bootloader code is there, right? Similar to that, the CLCD is also what it is doing. It is processing the data, it is executing the instruction. So for that, the CLCD will also have some startup code that we have to write. So that startup code, okay, startup code for the CLCD initialization. So we have to initialize the CLCD. So for that, we will be having the startup codes. It's not a complex thing, it's a simple thing only. I will show you. So here is the function definition, init CLCD controller. Now, where I have to refer that startup code, that will be available in the data sheet of CLCD itself. In the page number 43, you will be having 43 or 40, 45 maybe. One second, let me, yeah, it's on page number 45. Okay, it will be available on page number 45. Let me write this here also. Okay, for here you have to refer the data sheet of CLCD, page number 45, it will be available. Okay, in the data sheet of CLCD page number 45, the initialization, the startup is available. So here you are having one flow chart, right? This flow chart is nothing but our steps. Okay, for 8-bit mode, for 4-bit mode, we will be having the separate initialization. Okay, so the first initialization, this is for the 8-bit mode. Similarly, we'll be having the initialization for the 4-bit mode as well. Okay, so now we are following the 8-bit mode. So once you have powered on, then the very first step, we have to wait more than 15 milliseconds of time. We have to wait for some time. Okay, more than 15 milliseconds we have to wait, because in order to set up that CLCD. Okay, so here first, what we are doing inside this function, the first thing is I'm adding the delay. Okay, because they told to wait for more than 15 milliseconds. So I'm calling the built-in delay function. I'm providing some 30 milliseconds of delay. More than 15 they have mentioned, can mention any delay. So I'm mentioning some 30 milliseconds of delay. Okay, so after providing that delay, what we have to do? So here, the next step, we are having the data bits. D0 to D7, 8 bit of data bits are available. To that 8 bits, what value we have to assign, that also they have given, which is 0011, and the remaining 4 bits are don't care bit. To the data bits, what we have to write? 0011, and the remaining bits they have mentioned it as star, which is it is of a don't care value. You can write any value to the 4 bits. You can write any value to the 4 bits, all 0 or 1, 1 0 1 0, any combination of value you can write to the 4 bit. Okay, now MSB bit, what value I am writing? 0011. So since I am writing that value to the MSB, to the LSB also I am writing that same value. But this LSB value, you can write any value. Since I am writing the value here, the same value I am writing for the LSB bit also. So what will be the hex value of this? What is the hex value of this? Yes, 0x33. So now in our .h file of CLCD, have you remember here we are defined one macro, 8-bit mode, 0x33. I have defined one macro. For this only, I have defined the macro there. So now we have to write this 0x33 to the CLCD. So we have to mention whether the 0x33 is an instruction or it is a data. That information also it's already given. See here, what is the RS bit value? What is the RS bit value here? RS bit value is 0, which means 0x33 is nothing but an instruction, right? So now on our code, you can see here. Okay, after providing the delay, I'm calling the CLCD write function, and I'm passing the information as 8-bit mode, which is nothing but 0x33. Since it is an instruction, what we have to do? We have to pass the RS bit value as 0. So I'm passing the mode as an instruction mode. If you want to send the data, data mode. All these are macro. See here, instruction mode means 0, data mode means 1. All these are macros are available. I'm using that macro. So now after waiting for more than 15 milliseconds of time, we have to write the value 0x33. Now we have to wait for the delay. Again, we have to add a delay. How much delay? 4.1 milliseconds of delay. So as I already mentioned, like the microcontroller, sorry, the CLCD, it will take the maximum delay is 41 microseconds, which is nothing but what? 41 microseconds is nothing but 4.1 milliseconds of time, right? So I'll be adding that much maximum delay. Okay, so after writing that instruction to the CLCD, here you can see I'm adding the delay in microseconds, which is 4100 microseconds, 41 microseconds of delay I'll be adding. Okay, I'll be adding this much amount of time. I'm providing the delay in microseconds. Okay, so now after adding the delay, after waiting for a time, again what we have to do, write the same value to the CLCD one more time. So one more time we have to write that. So after adding the delay, you can see the same statement. I'm writing it here for the one more time. So after providing the delay, 4100 microseconds of delay, we have to write the same statement again. Yes, after writing that same statement, again we have to wait for some 100 microseconds of time. So I have to add, after this I'll be adding the delay for 100 microseconds of time. After adding the delay, again we have to write the same value. So after adding the delay, again I am writing the same value. Up to this, our initialization is already completed. So I'm just providing 1 microseconds of time. So here, in order to initialize our CLCD, to start up our CLCD, first we are adding one time, then we are writing that instruction, we are adding the delays as given in our data sheet. So up to this, our initialization is completed. After this, whatever the instruction or the data you want to send, yes, you can send it to the CLCD. So first I have to do the configuration, right? So two lines we are using 8-bit mode, 5 cross 8, so that I'm configuring. Then I'm clearing all the characters in the display. So for that I'm passing the clear display instruction. Okay, for all the instructions what we have to do, I'm just adding one kind of a delay in order to see that whether it is cleared or not, like that. So after that, on our display, I'm going to turn on the display because I'll be displaying some characters, and then cursor blinking. So here if I keep the cursor is blinking, right? The same blinking will be there on our CLCD also. So I'm going to stop that blinking. I don't want to blink that cursor. So initially the cursor has been turned off. So now these are all nothing but initialization. Once the initialization is completed, then we can write our values. Now in this initialization part, do you have any doubts here? In the initialization part, do you have any doubts? Okay. So now we'll move to the main.c. So in the main.c, I'm using only one peripheral called CLCD. So in the init config function, I'm calling the init CLCD so that the CLCD will get configured. So inside the while one, first I'm calling the CLCD putch function. So putch, what it will do, it will display only one character. So I'm displaying the character called H, and I'm displaying in the line number 1. I'm displaying in the line number 1, and I'm passing the zeroth position. Line number 1 is what? It's a macro. So what address will be passed? 0x80 will get passed. So H will be displayed on the line number 1. Then I am calling the CLCD print function. I am displaying a message called hello, where I am displaying line number 2 from the starting position. Okay, so we have already written that, we are just calling the function whenever you want to display. It is showing project is empty error. So let me close and reopen this. I'm building my project. Okay, so if you're getting this script engine not supported error, just create a new project and copy paste all your files. Let me create the project. So we have to select our device. Sorry, it's 18F, 16F. 16F877A is our controller. Select the compiler. Project name, I'm giving the name as clcd 8-bit. Okay, let me create this under your folder. I have already taken folder for your batch 022. Yeah, inside that I'm creating one project. Whatever the files are there, I'm just going to copy paste the same files only, no changes in that. So in the header file we have .h file, right? So just copy that file and paste it here. Okay, next in our sources we need this .c file of clcd. Copy and paste it here. Then we have to copy our main.c and paste it. Okay, now we can build your project. Yeah, now it is building that project. Okay, it's building our project. So build is successful and the hex file is also generated. So now we'll load our hex file, which is in users Lenovo. We'll be having the mplabx projects folder. We created clcd 8-bit mode dist default production, and I'm loading the hex file. You can see here in the line number 1 we have displayed the h. In line number 2 we have displayed the hello. Now if you want, we'll change the message also. Okay, so now what we will do, we'll display in different position, like from the position number 5. So you just need to change the position, that's it. Line number 1, from the 5th position I will be displaying the value h. Okay, I have edited the code, right? So I'm building my project. So like that you can pass or you can give any positions. Okay, build is successful, loading is also completed. So now we'll reload this. Now we can see 0th position, first position, second, third, fourth, and from the 5th position h is getting displayed. H is getting displayed. Similarly, what you can do, you can display the string on line number 1, you can display the character on the line number 2 also. Depends, you can change that also. So is the CLCD 8-bit code, is that programming is clear for everyone? Do you have any doubts in the 8-bit programming? Okay. Okay. So now we'll understand about that 4-bit. 4-bit also same only. There is no much difficulty. Only the same steps, but we have to assign the data. Only that will be the difference. Okay. So now same. Okay, I want to assign some value. In case of 4-bit mode, we will be using only 4 lines, which is from D4 to D7. Only the 4 lines we are going to use. The remaining 4 lines we will not be using. And here what we will be doing, we will be assigning our nibble by nibble. We'll be assigning the datas nibble by nibble. We will be assigning nibble by nibble. We have to assign our data. So now let's say same, I want to display a value called a. Okay, So we have already discussed that, I guess. Yeah. So in order to display any value, its hex value only it will be getting displayed, right? So if I want to display the A means it's binary and the hex value will get assigned. So now in case of 8-bit mode, 8 lines are there, we can assign that data. But in case of 4-bit mode, we will be using only 4 lines. So first what we have to do, among the 8-bit, first we have to assign the upper nibble. After that, we have to assign the lower nibble. Okay. Now, first we have to assign the upper nibble, right? Let me take the same clcd write function. Okay. Yeah, I'm taking the same clcd write function, no changes to it. But byte by byte, we have to assign. So while assigning the data, byte by byte, we have to assign our data. Please give me 1 second. Yeah. So we have to assign our data byte by byte. So RS bit value will not get changed, but in order to assign the data to the data port, that will be changed. Now we cannot assign our whole 8 byte of data. We have to assign the byte by byte. Now this is my byte of information. I want to display A means 0110. Okay. 110, then 0001, 8 byte of data, 8 bits of data we are having. Now from this I want to extract the MSB 4 bit upper nibbles. I have to extract. Okay, I have to extract what? The upper nibble. So only this bit I have to fetch, which is 0110. Only this bit I have to extract. Okay, I don't want to extract, I don't need the other bits, I don't need the other 4 bits, I want to clear it. So what we have to do, since we are setting a bit, okay, we are setting, like we are get, I want to fetch that, extract that. So these 4 bits it should be 1, and the other 4 bits I don't want, so I'll be making it as 0, right? So now here what will be the mask? 0x f0 will be our mask. 0x f0 will be our mask. Between these two information, we have to perform AND operation. So if I perform, okay, the byte of information and with 0x f0 means we will be getting only the upper nibble. We will be getting only the upper nibble. That upper nibble we have to assign it to our data port. So here first we have to assign the upper nibble. Okay, while assigning the data, assign the upper nibble first. So in order to assign the upper nibble only, in order to extract that, we perform 0x f0. So only that upper nibble we will be extracting. So then I am adding that delay. After this what we have to do, we have to extract the lower nibble, right? Now we have to assign the lower nibble. Okay, we have to assign the lower nibble. So this is our byte of information. Now from this byte of information, I want to fetch the lower nibble, which means I don't want the MSB bit, but I want to extract the LSB bit. I want to extract the LSB bits. Okay, sorry, I have added one more zero. Yeah, I want to extract the MSB bit, so LSB bit. So here what will be our mask? 0x 0f. Very good. 0x 0f will be our mask. So which means here we don't want the bits, I'm clearing it. Other 4 bits I want to extract. So now we will be extracting the 4 bytes, so 4 bits. So if I perform byte and with 0x0f means we can able to fetch our lower nibble of information, lower nibble of information. But that lower nibble is present from 0th position to the 3rd position. Now what we have to do, the lower nibble data, okay, we have to low the lower nibble data, we have to shift the data to the upper nibble. The lower nibble data, we have to shift it to the upper nibble. So after extracting our lower nibble, so I want to shift that, right? So what we need to do, we have to shift our lower nibble of data to the upper nibble. So LSB bits, I have to shift it to the MSB, which means which shifting? Left shifting. 4 times I'll be doing the left shifting. So if I do the left shift for 4 times, means 4 zeros will be added to the LSB side. So right, 4 zeros will be added to the LSB side. Now our lower nibble data, we have assigned it to the upper nibble. So what we have to do, in order to assign the lower nibble to the port D, we have to perform like byte and with 0x0f. This is to extract our LSB 4 bit. This is to extract the LSB 4 bit. After extracting that, I'll be shifting it for 4 times in order to bring the lower nibble data to the D4 to D7th bit. After that, what we have to do? Again, we have to provide the clock pulse in order to perform this operation. Again, we have to provide the clock pulse in order to perform the operation. After that, same delay only. So here what we are doing, first we are extracting the lower nibble and we are extracting the upper nibble. Sorry, here I made a mistake, right? So here it should be F. I have mentioned it as F. So it should be all the bits, it should be 1 only. I made a mistake there. It should be F. Yes, 0x01 will be our lower nibble, but our lower nibble is available from bit number 0 to bit number 3. But I have to assign the bit from the bit number 4 to bit number 5 only I have to assign. Because only these 4 bits will be taken as our data bits, right? So I have to bring that lower nibble to the upper nibble. That's why we are shifting. So here we are assigning our upper nibble first, then provide the clock pulse for that, then assign the lower nibble, provide the clock pulse for that. Only this much is the change for your 4-bit mode. Is that clear? So similar to the 8-bit code, we are having that 4-bit code also. Let me open that code. Yeah, in our CLCD sources, we'll be having the 4-bit driver. Okay. So let me open that 4-bit driver code and we'll close all the other files which we opened. Yeah. So here I'm having that 4-bit code. So we'll open all the files, whichever is necessary. Same clcd.c.h, everything will be there. So in the .h file, actually I didn't change anything. The same things will be there. Now we are using what? We are using the 4-bit mode, right? So here we have our function set. Once again, we have our function set instruction. One second. Yeah, we are having the function set instruction. Now here we are going to configure the 4-bit mode, but same 2 lines I am using, and I am using the same 5 cross 8 dots as well. So now what we have to do, the bits, it will be 0, 0, 1. Now we have to mention our date DL bit. Now the DL bit, it will be 0 since I am following the 4-bit mode. Number of lines 1 and the font size is also 5 cross 8, so it will be 0 only. It will be 0. And the other 2 bits, it's of don't care bit. You can write any value. Now in order to configure the 4-bit mode, 2 lines and 5 cross 8 dots, what is the hex value we have to load to the function set? What is the hex value we have to load to the function set instruction? Yes, 0x28 is the value we have to load. What value? 0x28 is the value we have to load. So here you can see we have changed that two lines. Okay, 5 cross 8 matrix and the 4-bit mode 0x28. I have loaded the value 0x28. Okay, so now we'll discuss the .c file of clcd. So no changes with respect to the put ch or the print function. Okay, only change is with respect to the uh, clcd, right? Okay, so what we have to do first, we are writing our, yeah, I will repeat it. So for the very first time we configured it as 8-bit mode, which means here we are having the three bits, our dl bit, n bit and f bit. So in the previous time we used the 8-bit mode. Since we are using the 8-bit mode, dl bit we have configured it as 1. One second. Yeah, dl bit, what we did, we configured it as 1. One second. DL bit we have configured it as 1, but now I am following 4-bit mode. So the DL bit, it should be what, 0. So instead of 1, I am making the DL bit as 0. And same number of lines, I am going to use 2 lines. So n bit, it should be 1. So number of lines, I am using 2 lines. So nth bit, it will be 1. Now to coming to the font size, I'm using the same 5 cross 8 dots. So F bit, it should be 0. So I'm making the F bit also 0. And other two bits are like, it is of a don't care bit. You can write any value to that bits. So I'm writing the value 00 to the other bits. So only this is the changes. Okay. Instead of the DL bit as 1, we have to make the DL bit as 0. So if I make the DL bit as 0, we'll be using it as a 4-bit mode. So since it is a 4-bit mode, we will be writing the value 0x28. Is that clear? Yeah. First make a note of this, no issues. Make a note of this first. Okay. Yeah. So now first what we have to do, we have to assign our upper nibble. Then provide the clock pulse. Then assign the lower nibble, provide the clock pulse. Only this much is the change for your write function as we discussed earlier. Now coming to the initialization part. So we know that for 8-bit mode, we followed one initialization step. The same thing we will be having for our 8-bit mode also. Okay, we have to follow for our 8-bit mode, sorry, 4-bit mode also. Now there is no change here. We are adding the same delay, but only thing is number of bits we are using. So here we are using what? Only 4 bits we are using. D4 to D7. The values are what? 0011, which is nothing but 3. Which is nothing but what? 3. So, for the 8-bit mode also it was 3. The remaining 4 bits it is of don't care. See, in 8-bit mode also it was 3 and the remaining bits are don't care. We can write any value. So, 0x33 is the value in the 8-bit mode. But for the 4-bit mode, 0x3. But if you want, you can assign that remaining 3 also, no issues. So, since we already wrote 0x33, so here also I am writing the same value, same macro I have taken, which means I am going to use same 33 as a macro. No changes here. Okay, anyhow, only bit number 4 to bit number 7 will be taken. Okay, even though I assign an 8 bit, we will not use the other 4 bits since I have configured as a 4-bit mode in the function set. We will not use the other 4 bits. So we just need to use only the D4 to D7. Even though you assign a value as an 8-bit, the LSB 4 bits will get ignored only. No issues in that. So I'm writing the same value. In the initialization also what we are doing, we are writing the same value as given in the steps initialization. Okay, whatever we followed for 8-bit mode, I'm doing the same here also. The thing is, after doing the configuration, we will be configuring this, but here we will be using 4-bit mode. For that only we have got the hex value as 0x28 is our hex value. So that configuration I'm writing. So above that I have added one more instruction called 4-bit mode. Actually, that step is also available in our uh, data sheet initialization part. So here you can see. So after adding the delay, after writing the data and all, the very first statement is, here you can see 0010. They are writing one instruction. So they are writing an instruction called 0010. 0010 is nothing but what? 2. MSB bit is 2. And the LSB bit, it can be zeros only. Anyhow, the value will not be considered. So 20. Hex value is nothing but what? 0x. One second. 0x20 or 02? It should be 0010, which means the MSB 4 bit it will be like a value 2 and the LSB bit it will be a value as 0 only. LSB bit value it will be a 0 only. Okay, this is the value we have to write. Why we are writing this? Again, after writing our 0x33, it is given in the same flowchart like we have to do this. That's why we are writing. But in your .h file, the macro is actually wrong. They have defined it as 0x02. No, let me check one second. 0x02. Okay. Okay. We are calling the CLCD, right? So first we will be assigning our MSB bit, no issues in that. We will be assigning the LSB bit also, no issues. Yeah, you can, here you can write 0x02 or you can write 0x20. Any values you can write. Why we can write any value 20 or 02? Why we are having an option like this? So why we are having an option is, on our initialization, they have mentioned it as we have to write this value from the D4 to D7. We have to write this value for the initialization. It's a part of the initialization or the startup for the CLCD. So why we are having this option? 20 also we can write, 02 also we can write. So For example, if I write the value 0x20, first nibble by nibble. So first 2 will be assigned. After that 0 will be assigned. No issues. To the data bits, only I am assigning 4 bit of value. Or if I write 0x02 also, here also the same thing. First we will be assigning 0. Second time we will be assigning the value 2. So the thing is, I have to assign 2 for the CLCD. It doesn't matter the previous value whatever I'm assigning, or the after that 2 also whatever I'm assigning, it doesn't matter. I just want to assign 2. It can be upper nibble or it can be a lower nibble. 20 also it will work, 02 also it will work. Why? Because the remaining 4 bits anyhow it will be ignored, right? That's why. So here in the initialization, after writing the 3, we have to write the value 2. This is a part of our initialization for the 4-bit mode. Followed by that, the remaining things will be there, like function set. What is the value we have to write? Display on, clear the display. Whatever the other instructions you want to do, you can do. So that's why in our programming, after doing that initialization for that 8-bit mode 0x33, again we are writing one more initialization which is for the 4-bit, that 02 we have to write, right? So that macro I am calling. After that I am configuring my initialization for the CLCD, like initially the display should be on, cursor should be off, clear the display. Like that I am adding the extra instructions also. Now, do you have any confusion in this init display controller? Do you have any confusion here? Okay. So now the same code only in your main.c also I am displaying the same thing. Have taken different positions in order to display that. Okay. So in line number 1 I am displaying the W, and in line number 2 I am displaying the world. Yeah. Let me build this project. Okay, so same output only you will be getting. The main difference between 8-bit and the 4-bit is number of lines which we are using, only that is the difference. Yeah, build is successful. Let me load this hex file. 4-bit mode. So now we can see. So in line number 1 also we have given fourth position. Line number 2 also we have given fourth position. Our characters are getting displayed. Line number 1 I displayed a character, and line number 2 I have displayed a string. Now what we will do, in the line number 1 will display a string. Okay, I am displaying a message called hello. Okay, but if I want to display a string, means I want to use which function? Print function only I have to use. So in both line number 1 and line number 2 I am displaying a string hello, and then world I am displaying some message. We'll build the project since we edited the code. Build is successful. Hex file is also updated. Now we'll reload this. One second. I didn't build that one. Yeah, we'll build this. Uh, I didn't set the project as a main project, right? So main project is what? CLCD 8-bit. So previously I compiled CLCD 8-bit only. I didn't compile the 4-bit. Yeah. So I have compiled this 4-bit code now. Okay. Now we'll reload this. So now you can see. In line number 1 also string is displayed. Line number 2 also string is displayed. Is that clear for everyone? CLCD 8-bit mode and the 4-bit mode. If you want, you can make a note of this also. Okay, first we have to assign our upper nibble, provide the clock pulse, lower nibble, provide the clock pulse. If you want, please make a note of this also. Yeah, make a note of this. If you have any confusions or if you have any doubts, please post your doubts on the chat box. Ma'am, to make it as a main project, we need to click on the project and build. Yeah, not like that. Like you can set a project as a main project. You can see our 4-bit code is not a main project. So you can right click. Okay, you can right click. And here if you go, you will be having an option. Set as main project option will be there. You can select that. Now you can see the background is it's like the text is in bold. If it is in bold, that is a main project. So if it is a main project, if you click on this build icon, it will be building the main project. Okay, or now if I want to build this clcd 8-bit mode, means now we can see this is not a bold in color. This is not our main project. So what you can do, if you don't want to set it as a main project, just right click the project and you can give the build option also. This will also work fine. Okay, so this build tool icon, it will always build the main project. This build it, you can select it for a particular project. Yeah. Okay. So CLCD completed. We'll stop here. We'll continue on next session. So already I have shared the schedule. Like tomorrow you don't have a session. It's a holiday. We'll continue on Wednesday. Okay. So now you all can mark your attendance and you can leave the session. Yes. Everyone, please mark your attendance.